Maybe you okay?
Recording has started.
I'll be fine. Just a little bit of the flu. Okay, so for today, what we're going to look at is dial calipers. We looked at rulers and tape measures yesterday a little bit. Calipers are a little bit more of a precise measuring device, partly because it's a surface-to-surface measuring device, which means we actually touch the surface with the device to set it to read its length. Now, there are actually 4 different types of readings that can be taken on a dial caliper. First is just an inside measure, or an outside measurement, I should say, where you stick it between the main jaws here, which most everybody's familiar with, the main jaws of the caliper. You put an object in between there, just like that. And that's the main use of the caliper. That's what most people use it for. But there are 3 other types of measurement it can be used for. It can be used for measuring inside faces. So these jaws up here, when I turn on my drawing here, when these jaws are tight together, this surface and this surface are also lined up so that they spread out at the same measurement as the main jaws do. So we can do an inside measurement like that. Next, we have a surface-to-surface measurement, or a step measurement. When we're looking at these jaws here, this edge right here, when the jaws are closed tight, exactly lines up with that edge. And since it's a little bit offset, we can use it like this to measure a step up. And then finally, we have a depth gauge. This little piece that can sometimes be annoying that sticks out as you open up the micrometer is actually a depth gauge. I know some people that have cut those off because they get bent or whatever, but they actually do have a purpose there. So those are the 4 types of measurements we can take with our caliper. Let's take a look at how do we read these calipers. Well, first of all, this is an inch caliper. 2 ways that we know. One is there are 2 different numbers on 2 sets of numbers on the main scale here on the blade of the caliper. And second, this goes to 1/1000th in here. Now, a lot of them would even say 1/1000th of an inch, but this one does not because it wants to force you to understand that if it says 1/1000th, it is talking inches. Depending on the caliper, there is always a surface here that lines up with 0 when the jaws are closed. On this caliper, it's this edge right here. So we read the main scale at that edge. So this is 2 full inches and 5/10. That's 2.5 inches. And then we go over to the dial that says 15. That is 2.515 inches. So for something like this is 5.6. This edge is definitely past the 0.6. And then the dial is at 21, so 5.621 inches. This is 3.6 and 66, for 3.666 inches.
It kind of looks like
Go ahead.
Like it was going to 7. Do you always just, if the number is fully visible, then it's that number?
I'm glad you asked
Because
that.
it kind of looks.
That's what this next example is going to show for you. You can see the 9 is fully visible, but we can't tell if the line is sticking out or not. So this is definitely 4 inches, but we don't know if it's 0.8 or 0.9. But if you look here, we have not quite made it back to 0 yet, which means we've not quite made it to that line yet. So this is only 4.8. And then, of course, that's 87. So that's how you tell when you see, like here, you see the 7 exposed. Well, this is not quite back around to 0, so it hasn't quite made it to that next number yet. Then, of course, this
Thank
one,
you.
you bet. This one here is 0 point. Again, you see the 3 exposed. But again, we're not quite back to 0, so that's 0.2 and 7.1. So here's a little bit different style caliper. This one actually says thousandths of an inch on the dial. And for this one, it's not the edge of the jaw that we line up. When this jaw is closed, it is this spot that lines up with 0. So we read our main scale there. So this is 0.5. I think these are a little bit easier to read because you can tell it's not to the 6. So 0.563 inches. This one, again, we can't quite tell if it's past the 8 or not, but we look at the dial and we have just passed 0, which means we have just passed the last tenth. So that is 0.8. We have passed the 8. 1.4. So here, this is 1 point. We're not to the 1 yet, so it's 1.0. We have to be careful to include that 0 there because otherwise our place values are going to be all screwed up. Sorry, I just had instant message pop up. It kind of distracted me for a second. So it's 1.0 and then 4.6 inches. We can have a 64th of an inch caliper. In a 64th of an inch caliper, it's just that. It's a 64th of an inch. Now, there's 2 ways you can read these. One is there's the main scale here that has the full inches. We need to read at least the full inches off the main scale. Oops. And we could just read the main scale down to the 16th of an inch because those are the 16ths on those marks. Or if we want to go down to the 64th of an inch, which is what the dial indicates for us, we can just take the whole inches off the main scale. That's 1 inch. And then we look at the dial. So what I usually do is I find one that's labeled that's close to where my needle is at. That's an 1/8 inch, and I'm going to convert that to 64ths. Well, an 1/8 inch, 8 times 8 is 64, so 1 times 8 is 8. So that's 8 64ths. So I'm going to count up. That's 9, 10, 11 64ths. So we're between 10 64ths and 11 64ths. Which one do you think it's closest to?
11.
The 11, okay?
Because I would think about rounding up.
Yep. Yeah, and it's really close to the middle, but I would agree that it's slightly closer to the 11. So it's 1 and 11 64ths of an inch. So this one here is 0 inches. I would start at the 1/2, which of course is 32 64ths, and count up 33, 34, 35. So this is between the 34 and 35 64ths. Which one would you say it's closer to?
Again, I'd go 35.
I would agree, 35 64ths. Now, the good news is the 64th of an inch micrometers don't come into use a lot anymore. They were used for cabinet making and furniture making, and many of the cabinet companies in the area have gone to decimal inches rather than 64ths of an inch. So, got to get to this one here. This one's metric. Of course, it says 0.01 millimeters or 100th of a millimeter. The main scale here is actually labeled in centimeters. That's 1 centimeter, 2 centimeters, 3 centimeters, and so on. But the main scale's in centimeters and the dial's in millimeters. We can't mix units like that. So what we actually do is we read the main scale. This is read as 10 millimeters. That's read as 20 millimeters, and so on. So if I'm looking here, I'm trying to decide if that's past the 3 or not, which remember that 3 stands for 30. We have just passed 0 on the dial, which means we have just passed a main division on the main scale. So that is 30. And then the dial is 3.1, so that is 30.31 millimeters. What people generally find tricky, switching back and forth from metric to standard calipers, is the location of that decimal point. Now you see here that there are 2 digits in front of the decimal point, whereas at the standard caliper, there's only 1 digit in front of the decimal point. And we'll flip back and forth here in just a minute. So for this one, that's 20. One, two, three. Are we to the 4? Well, no, we're not quite back to 0, so we're not quite to the 4. So that's 23.96 millimeters. For this one here, this is 50. 1, 2. We are definitely past the 2. That's 52.41 millimeters. And this one here, we got 10, 15, 16, 17. Not quite to the 18 because we're not quite back to 0. But 17.77 millimeters. And of course this one, it's less than 10, but have we made it? We're right on the 9. We've just passed 0, so that means we have just passed a line on the main scale, so it is 9. And that's 1, 2, so 9.12 millimeters. So it's important that we be able to go back and forth between metric and standard. So this one you can tell is a standard. It's an inch micrometer because there's 2 sets of numbers here on the main scale. So this is 1 point. Have we made it to the 6? Yeah, we've just passed 0, so that means we did just pass the 6. So it's 1.609 inches. This is 1.261 inches. Well, this one here, we're back to metric. First of all, it says millimeters on the dial, but there's also only 1 set of numbers on the main scale. So this is 20, 21, 22.37 millimeters. And here, this is 25, 6, 7. Have we made it past the 8? Yes, we have, because we've just passed 0 on the dial. So it's 28.28 millimeters. Here we know we're back in inches because there's 2 sets of numbers on the main scale. We're not to the 9 yet because we have not made it back to 0, so this is 1.896 inches. 2.1, and then 37 off the dial, inches. So I'm going to have you read this one in your notes. So this is millimeters. This is 27.60 millimeters. Now, as from our discussion yesterday, do I need that 0 there? And the answer is yes, we do. This is measuring to the 100th of a millimeter, so we need to make sure it is expressed, our measurement is expressed to the 100th of a millimeter. I'll have you read this one in your notes. So this one is inches. This is 4.4 and 43, so 4.443 inches. We'll have you read this one in your notes quick. So this is 1.142 inches. We'll have you read this one quick. So this is back to millimeters. So this is 46.50 millimeters. We'll have you do that one. This is still millimeters. This is 86.81 millimeters. So that is our all the way back through to get to my that's the basics of our calipers. I might have lost my connection to my external drive here. I had some applets that I could show you a little bit more. For right now, we are going to stick with regular dial calipers. There's something out there called a vernier caliper. It's really kind of an ingenious little scale. The vernier scale, Vernier was the name of the guy who invented it. And what it does is without the oops. Let's see if I can get it back here. There we go. Without the dials, and for many years the dial calipers were not very precise because it was tough to manufacture dials that were precise enough that they worked well. There was always a lot of slop in the dial calipers. They have since fixed that. Dial calipers are the standard in the industry now. They are pretty precise. I hear people all the time say, well, I'll just use a digital caliper, which is fine. But first of all, if you are going to use a digital caliper, if you're not spending $300 or $400, you're not getting a good digital caliper. Also, you need to make sure that you calibrate it literally every few hours. Okay, so this is a vernier caliper. This is a metric vernier caliper. The way the vernier scale works, you can see that there is that extra set of numbers right here. And so this is the main scale up here. You can read the main scale at the 0 of the vernier scale. So right now it's closed, which is saying the main scale reads a 0. If you look at the vernier scale lines, you can see they don't quite line up with the lines on the other scale. In fact, they're 1/1000th of an inch closer together than the lines on the other scale. You can see as we get up here, this line is actually exactly one line off. So when we open this up, we read the main scale at the 0 of the vernier scale. So this is 41. You can see it says 41. And then I have to read the vernier scale. I have to figure out what line here lines up. Now this is, technically this is 10, 20, 30, 40, 50, 60. So this is 12, 14, 16, 18, 20. Now I look here, this is almost to the 42, so I'm going to look up in the upper end here to see what lines up. Now because of computer pixels being limited on a screen, there's 3 or 4 of these, or 4 or 5 that look like they line up. All of these here look like they line up from about 87 through 91 or so. Look like they line up. And this is where there's that weakness. If I actually had the dial caliper, not the dial caliper, but the vernier caliper in front of me, I'd actually tip it and I would look at it on edge like this, so I'm looking down the lines. And by doing that, it's easier to see any slight deviation from being lined up. This one is saying it's the 88 that lines up. So this is 41.88 millimeters. By the way, I should mention that 41, the comma instead of the decimal point. This is German. Stefanali is a German company. So they created this applet in many other countries, the comma is used instead of the decimal point. And like for 10,000, they don't use a comma, they just use an extra half space there. Okay, that's a dial. Don't want to look at the dial again. Okay, so here is the inch vernier caliper. So our main scale is just like before. Again, you see that the vernier scale, the 0 lines up with the 0 when it's closed. So we'll read the main scale at the 0 of the vernier scale. You'll notice here that instead of just being 1.1, 1.2, 1.3, that there's lines in between them. Those are quarter marks. So let me put this right here. That's 1.1 and 3/4. So that's 1.175 is what that's telling us. And then this here, 0 through 25, we see what lines up there. It looks like the 11 is lined up. So 1.175 plus 11 gives us 1.186. Now, I will not make you read vernier calipers in this class. I'm showing you these just to kind of give you a chance to appreciate how much simpler some modern technology has made things. But I wanted you to see that vernier scale and see how it works. It really was a kind of ingenious thing to just make the lines 1/1000th of an inch closer together than the regular lines on the caliper, so that you could read that extra degree of precision there. Okay, I think that's about as far as I'm going to make it again today. So there is a packet in Blackboard on reading calipers. There's also a worksheet there on reading a tape measure, just to give you a practice on getting the correct units on the tape measure, if you'd like that extra practice. Other than that, that is all we have for new material for today. And